Can you hear me well? Just to confirm.
Yes, very well.
Thanks, Millicent. So without further ado, I will let Lewis start his presentation, but a bit of bio. Lewis works on composable systems for measuring, optimizing, and exchanging data sets across the entire data generating process in ML. In regular intervals, he shares his ideas through computer code and longer text spanning topics such as data optimization, ML data format, and measurement tools for ML systems. He also enjoys promoting opportunities for community. He helped initiate machine learning venues such as data-centric machine learning research, AI for Good, organized by ITU, and co-chaired conferences such as Machine Learning for Health, iClear, and the MLR workshop series. He is currently head of machine learning at Swiss company called Photon. On a personal side, we know Luis for a few years. We have been working together in organizing a few workshops, conferences. We met in Kigali last year, in Senegal, first time for him and Aisha, not maybe for you, to be here in Nairobi, but I will let him start, and then any question you may have, write on the chat, I will follow up, but also at the end of his presentation, you can go unmute and ask the question yourself. Again, apologies for the delay and thanks for joining us. Luis, the floor is yours.
Right, so first audio check. I think we are fine, but online, is this okay?
Yes.
Perfect. So first, I brought some snacks actually, which, yeah, you can mute for like 10 seconds because unfortunately we cannot send it through the microphone. But if we had a long session prepared, I thought it's too exhausting. We can have some candy. For you. It's from the some baklava. Feel free to pass it on.
Yeah, pass it down first.
All right, the talk is done.
That's all we can.
It's the space here.
All right, so just time management wise, we have like an hour, or how much did we schedule for? Like an hour and a half?
Yes, it's almost 1 hour at least.
Okay.
Then we could, yeah.
Okay.
Until 6.
Just to keep it a bit in check. Thank you so much, for organizing this. This was like a bit serendipity. We had been planning to meet with Germa and Aisha in Nairobi, and now we also have our little extended research family here to discuss a few things. I think the original idea was to catch up and think a bit on some kind of parallel activities. Germa and I, we kind of chat on a regular basis to just touch base on things where we can connect some dots. And my thought was in that spirit, so to give a bit of an overview of things that are currently happening along this kind of data-centric research agenda. And hopefully, we can also have a bit of a discussion. So feel free to chime in. This shouldn't be too much of a monologue. I have enough stuff for a monologue, but it's just if you're shy. So So the title, the most creative title I could come up with, Fever Dream. The reason I called it that is because there's a bunch of moving parts that are all connected towards a vision of building systems in machine learning more easily. And I want to kind of start a bit high level at the assumptions. So what, for me, the motivation behind this type of work is, and then going into some of the branches that we have been working on, covering the data generating process, and then infrastructure and a bit an outlook into the future. Okay. If there's any audio issues, things not showing as they should, too small, especially for the online folks, please just scream or raise your hand and then we figure it out. Okay, so my personal view of the very 10,000 feet of machine learning is something like this. So we have this substrate on which we run all our marvelous research or tasks, or also in industry, which consists of different components. And I think at least in the research community, usually there is some differentiation. There are some sub-communities that have their own conferences. So often, for example, the systems folks that meet at MSys or some of the database conferences, they don't talk so much to the folks that attend NeurIPS. And the optimization folks, they might be at NeurIPS, but they also have some of their own conferences. So the kind of overarching goal here is to find connections between the concepts that we develop and discuss in these different sub-communities to make this substrate more efficient. And overall, the rationale behind this, so why would you want to connect it? It's not just for the fun of it, or for some perverse kind of fascination with connection. It is to reduce the transaction cost in machine learning. So transaction costs, what I mean by this is every time you have to dig into some obscure data format to start with your ML model training, or if you have an ML model from Hugging Face and you want to modify it a bit, or I don't know, many people, I think, for example, use YOLO in their research and has a wonderful API. It doesn't have such a wonderful kind of low-level modification. And I think these are sometimes trade-offs that are hard to completely abolish, because if you want high-level abstractions, then you kind of go away from the very low-level code. But the goal here is to find more and more sweet spots where if we want to do something new, it is less costly in terms of time and the dollar numbers to do that. And the way I think this can be achieved is by making sure that these parts here that we have in the substrate, that we have closed the gap more and more and make them connect more and more. So that's the rationale for the connection. And I think, I mean, this applies not just to machine learning frameworks, but to a lot of systems design in general. There are some just general challenges in doing that, because firstly, it's usually frameworks that it's like a car that you assemble while driving it. So we while we dream of the perfect ML framework, we need to do already our ML. So we use PyTorch or JAX or whatever, and then we have some path dependencies and some technical depth in that. So that is something that is just inherently what will probably always be there, because we want to use the technology, but we also want to improve it. The other kind of challenge I already alluded to in the beginning is where we have communities not really talking to each other so much. So some of you are probably familiar with this metaphor of the man and the blind elephant, where everybody touches a different part and thinks it's a snake or whatever, while at the essentially they're all trying to kind of get a whole picture of the same thing. And that has some implications when building stuff similar to this kind of Babylonian tale, where if we don't have these things aligned well, it's hard to make good progress towards that kind of big ambition. All right, so that's just a bit to set the scene. I want to go in a bit in kind of in the following sequence. So I think when I met Girma, I think around 2020 or 2021, I was already quite familiar with some of the work he was doing with Celia and also with Skylar, especially the subset scanning stuff. And to me, I think that captures already some of this, like some spiritual nugget of this philosophy. What I really like about it is that we treat machine learning models as kind of an object like that we observe, like we observe objects in natural science. So if you think of activations as a kind of a set of things, rather than trying to just isolate single neurons and interpret them, but looking at it as a whole and then detect patterns. That I think is a very natural way to approach some of these composability problems, because we can abstract away from individual implementations and can go towards a bit more a general object or category of concept that we can apply. So I want to go a bit from that kind of start to look at this kind of let's say measurement view. I will explain in a minute a bit more what I mean by that, and then go towards the actual object of interest, which is the data generating process. And my kind of a bit steep hypothesis is that maybe machine learning all is just the measurement of data generating processes at different parts of that life cycle. So I want to look a bit into that, and hopefully we can discuss together. The thing that, at least one of the lessons that I took away from studying data generating processes vis-a-vis this measurement goal is that you quickly run into some roadblocks if you don't have the systems behind it set up correctly. So this will be kind of the third part I want to touch upon, which is the infrastructure to actually do measurement on these data generating processes. And then I hope we can have a bit of a discussion. So this is like all like very aspirational and like, oh, this would be, some of this works, or not to kind of sell ourselves short. So a lot of this works, but I think it's good also to have a bit of a reality check and mention the stuff that's shitty, and taking that to look at a few things that are currently happening in this space. So with Girma, we had a lot of discussions around a concept like a global index for machine learning tasks, and I know many here at Microsoft with the AI for Good kind of mission behind it have a very strong kind of pedigree towards this type of work, where we need to find we need to curate the data sets and the problems, but we also need the stuff that it can run on so that people can actually search it. So if a class of students wants to do some new assignment on whatever the latest transformer architecture might be, they can maybe spend all those accumulated GPU hours on a small problem that can actually have impact. And how you measure that impact is its whole own can of worms, which I think we can only address by kind of going back to that first point, is we have to have like measurements and the associated metrics. They will never be perfect, but often we don't even have the two. So that's already a big step up, in my opinion. So I don't know how to call this, kind of Quo-Vadis or something like this, and then future. So let's see how much of this we actually get done. Probably, well, I don't know. We have to stop somewhere or speed run this a bit. But that's kind of what I wanted to discuss and I thought about and prepared. Let's maybe dive in. So I want to have a look first at this kind of metrological or this measurement view. So the first bubble that I had on the screen. By the way, I rechecked. So these I think are the papers I read by you guys. So there was one that you guys did for a workshop, I think, and then there was this paper.
Amy,
yeah, I don't know where it was, on a health workshop. I'm sure. I'm not sure which one it was. Yeah. And then you have this Ishkai paper.
Back when we cared about healthcare stuff.
Yeah, exactly.
Feeling old.
This is the foundational work of synthesis at all, right?
Exactly. Exactly. Subset scanning for the win. Yeah, just a little throwback. Yeah, let's go back to this to this measurement. Yeah.
Don't feel that.
So in science, we have this concept of metrology. ITU, one organizations that also Gilma worked a lot with, and that I work with every now and then on technical standards. They do that basically for a living. So they write down what is a second and what is a kilogram and how you actually measure it. And I think if we want to do that in machine learning, we have a big opportunity. And there is a lot of cool communities exploiting exactly that angle. I'm sometimes surprised that it's not mainstream yet, but we had a really nice workshop at, or not a tutorial at iClear, I think this year, called The Physics of Large Language Models, which I think is in that type of spirit. It's trying to look at this model as we look at organisms in natural science and then observe them. But we have this nice advantage in contrast to like the natural world, where kind of things are like connected, that we can isolate it, we can rerun things, we can perfectly observe it. It's still complex, so it's not easy to understand, but it's observable, which is, I think, a huge opportunity for this measurement. So I already touched upon this kind of this elephant challenge. I think another really pervasive one that permeates also different like scientific communities in ML. Like the lab where I was before we started the company in Switzerland, we work a lot on interpretability, and I think we did some really good work. But from that time, I also know this community a bit, and I think that's one where this challenge is super acute, where we start to we want to measure something, but we are not clear on the metric, and then we start to kind of put a human lens on the thing, which is as of itself, if that's the requirement. But I think it sometimes happens not in an explicit way, and this is where it becomes, I think, challenging and can also introduce, some complications when we do an analysis. And the example I always like to bring is this Gaussian annulus theorem. So this is not to stump anyone. It's just like I think a neat little visualization of how unintuitive kind of machine truth can be from like human view truth. And the basic concept here is, or the basic point here is that if you look at the kind of center of mass for Gaussian in 1D, no surprises. It will be somewhere, around the mean or exactly at the mean. You will have the same center of mass for a 2D Gaussian, but if we already when we leave 2 dimensions, we get some funny business where this name of the theorem comes from, where the mass, the probability mass, actually concentrates. Like if you look at it as a sphere, it doesn't concentrate in the center as you might think, but it concentrates in a ring around the sphere, and that holds for like higher dimensions. But it is, when I first read about this, I was like, this is not what I would have expected. And there's many examples like that. Same if you go for distance metrics, like L2 distance and stuff like this. If you go to higher dimensions, these intuitions that we have from the world that we observe and that we live in often don't translate. And I think my kind of take on this is that if we want to measure stuff, we need to be very clear. It's okay to say, look, the model should be interpretable by this and this token. But I think we need to be explicit. And I would prefer if we have this goal that I showed in the beginning to reduce the transaction costs, which essentially just means that we basically we are penning for gold, right? We're penning for like the optimal data state, like in representation learning. We want to find the state of the data that allows us to solve the task with the least amount of compute and dollar. So that means bending the measurement towards the machine truth. So what is best for the machine to do the task? And for that, we need I think, explicit metrics that capture this notion. And obviously, there's the documentation path. There's this nice work by, I think her name is Crawford, an artist who maps out like large-scale AI systems. I think this is some recommender system from Facebook or Amazon or something. But the idea here being that if we want to do this measurement, we obviously need the documentation behind it to run it. And I want to give you like a quick example what I mean by this, because for now it has been like very abstract concepts and okay, we need measurement and some infrastructure and we want to reduce transaction costs. What does all this should actually mean? So to put this into a pipeline, this is from a health use case that we've been working on at different sections of the pipeline over several years. So if you do microscopy with blood smears or histo slides, at each step of the value chain where the data is generated, you can make some choices around the design to make this measurement possible in the first place, and then exploit your ability to measure it to make the representation or the data generation at each of these steps optimal for the downstream task. And I really like this this paper to illustrate this idea. So this is from a few other folks, which is in a similar vein to this Gaussian annulus theorem, where they pre-trained different models, like self-supervised pre-training for different models on different data sets. And they show how far you can actually get by just using random, for example, these dead leaves textures, which is just a few lines of Python script. So if you do that using the features, you can already get very high performance on ImageNet for downstream fine-tuning, vis-a-vis maybe some style gun images or some images, for example, from the Clever dataset, which are actual natural scenes, right? And it's very prevalent, I think, the notion in machine learning that we need natural distribution shifts and things like this. And I think for many robustness testing, this applies. But again, hammering down this kind of like idea of if at the end of the day, the only thing that matters is we need to ask the model what it kind of needs to survive and do well. And if you can get by with like very cheap random data to kind of go beyond some reference data that you actually had to acquire, then we are already quite far in this low transaction cost regime where, just a few lines of Python code can give you like a good backbone to start with. So how does this play out in an overall pipeline? When we ask the model what it wants, well, one way to do it, for example, is to emulate or extend the machine modeling beyond our kind of traditional confines. So usually when we do machine learning with images, we expect there's some bucket or some TF records or some like file system of whatever PNGs, JPEGs, or if you have some special measurements in radiology, you expect those measurements, but we usually don't go further back in the value chain. One way to address this is to try to model that next step. And this is what we did in this data model work, where we imagine we have a microscope, and instead of just having that microscope, we built a virtual microscope in PyTorch, which emulates the image signal processing of the microscope once the photons hit the sensor. And when you do that, what you can do after the fact is basically take these photon readouts, pipe them through this virtual microscope, and make it all differentiable, so that you, during training, ask the model not just to update the weight of its own kind of parameters, but to propagate it all the way back to the camera so that it can pick the acquisition setting that it wants for solving the task. And that is actually very task dependent. I'm going to skip ahead a bit to show the difference, or maybe just to get some context. This is kind of how this looks like. So we have the standard ML pipeline back here, right? So we do our little albumations or whatever on the images. We standardize it, we augment it, and then we have our task model that spits out the labels that we want for our respective tasks. Now, if you do this emulation, you basically have access to the stuff that happens on the camera. And for all of these functions, some of them have more parameters, like some of them are like a convolutional layer, you can imagine. Others are like very simple, so they just have 2 or 3 parameters. But all of these are now differentiable, and we can just ask the model during training, okay, look at this whole parameter space and just pick what you want. And this is very task sensitive. So it's not a kind of unilateral, always ask the acquisition and you get better results kind of story. So we had 2 tasks that we benchmarked this with. One is, like I said, this kind of histo with blood smear task. And the other one is Earth observation data that we acquired with drones and satellites. And what you see here is, let's start maybe on this side, which is the most clear. So frozen means it's just the standard pipeline. It's how the image comes out of the camera. Learned is the whole learned pipeline. And you already see that you have a bunch of artifacts here. To the human eye, you would probably say this looks shitty. A doctor would probably complain they cannot see clearly. But actually, for the validation metric, we see that we converge a lot faster and get overall slightly better results, though here it also saturates for the frozen setting, as you can see. So there's also some error bars around it. And I would say, so if you are not going beyond like these optimization steps, you have a quick win. But here are already they are saturating like to kind of similar degree. Here it's for low intensity data, which means that they have less exposure and less photon counts. It already becomes a bit more crass, the contrast. Now compare this to the drone data. The model doesn't really, take this into consideration at all, which also makes sense because the first task basically is identifying very fine-grained cells. And then for the drone segmentation task, it just had to segment like big blobs of cars and houses, which don't really degrade a lot or can be improved upon a lot because it's quite coarse, the object boundaries. So the model also didn't really get any value out of this optimization. But this kind of stuff you can only do once you kind of push this measurement paradigm closer to or further in the data generating process. And that's kind of the spirit behind this measurement view that I mentioned in the beginning. I think if we want to do this type of optimization, we obviously have to do the legwork of providing frameworks that allow us to do the measurement. Maybe one more like comment on this, or a bit also transitioning to this the question that follows. So if we can ask the model in this setting for the optimal acquisition setting, what then about completely synthetic data, right? Remember, this is data that we took. We have the raw photon counts, and then post hoc we can do those evaluations, but you still need like a small reference set. But for synthetic data, there has been a lot of discussions around their value, their utility, and in my slice of the experience that I had in papers where we evaluated this, it's actually quite similar. It's super task dependent. So there was this paper last year. Let me see. I still find this. I don't know if you came across this. This is from Yarin Gal's group and a few folks there at Oxford. So when basically the whole the whole hype around synthetic data from generative models reached the peak, they came out with this model collapse paper, and when they make a reasonable kind of analysis, and I think also point, so they're basically saying, okay, imagine you train a generative model. So each of these boxes is a model, and you have your first generation of data, which is maybe harvested from the internet, and then you sample from that model, and then you train your next generative model on it, and so on and so forth. So after n generations, basically you went through n of these cycles of you have data, train the model, sample from that model, use that data to train a new model, and obviously you can expect some kind of deterioration in the statistical approximation. This is also the point they make here. So if you accumulate those approximation errors because you only have finite samples, then you will probably deviate more and more from that original distribution. And then the question is how much kind of value this nth generation model can provide if you use that for fine-tuning, for example, another a task model, right? Because that's how we would ideally like to use this data that we optimize for downstream kind of evaluation or downstream fine-tuning of tasks, which, to be fair, I think has its own little weird like chicken egg problem, because maybe let's go back for a second. So this is something that we presented at NeurIPS last year, where we stick with this histo case and train a diffusion model. It's a bit special because it also uses some segmentation mask information to provide some guidance to the synthesis process. So in this like overall pipeline, right, we are now one step further. So if we model the camera, then we can basically do with those raw measurements. But what if we want to go further, right? Like if we want to already basically emulate reality, we have to do something like generative modeling because we don't have a measurement to begin with. We have to create one out of thin air. And that's where we use diffusion models so that we can start with noise and then guide it towards a scene that we can consume. And the main kind of like we were working through this, and we got some nice results, but the chicken egg problem that always kept popping into my head is like, okay, now what are we doing here? So we are training a diffusion model. We had always issues to get data. Why do we have issues to get data? Because we are trying to train a generative model for use case that doesn't have a lot of data. So this kind of is in conflict, right? So if you want a model that generates data, then you need a lot of data to train it. Usually you want that data for settings where there is none. So it's kind of, it's a chicken egg situation. And that's also where I think, there's some like deep conceptual limitations. It doesn't apply to all settings, but especially in healthcare, rare diseases, and just many starting points where people think, oh yeah, let's do synthetic data with a generative model. You can start with a just good foundation model and then work your way kind of backwards. But the results, they don't lie in the end. And here for us, it was again very varied and very heterogeneous and task dependent. So let me just walk you through this thing quickly to parse the results. So what we basically did is, so in-house, so IH is in-house data. So you can treat this as basically from a similar distribution. In-house 2 and 3 already have some factors of variation because they were quite in a different center. And then the further we go to the right, the more different, at least, the distribution should be. I put an asterisk on this because, like we discussed in the beginning, how different that is. In the end, you have to ask the model. But they were acquired at completely different sites for different indications. So they are not really overlapping with the original use case, which is just the histo on the skin samples for the different patients. So then what you see here in the columns on the left is we have a downstream classification model that sorts out whether there's cancer present. So it's just a binary classification task, just trained on the real data, trained on just on the synthetic data, and then trained on augmented data. And for some settings, you actually get a slight boost using the synthetic data. For other settings, it's actually better to just stick with the real data. And for some, you get a boost when doing the augmented. But there's no like clear across the board trend where if you always supplement with synthetic data, you get better. And I think this picture is also starting to emerge. So in this critical discussion around model collapse more and more. So the paper I showed by Yaringal and colleagues was kind of was a really nice discussion piece. But we had a workshop at ICML, a DMLR workshop that we hold like once a year or so. We try on data-centric machine learning, and Matthias, who's now based at Stanford, I think they made this now into a full paper that they presented at Croissant. They made this really cool analysis on model collapse, because remember also there are some broader implications, right? So if people are afraid that, or like big picture, right? Like if you think 10 years ahead, if we now have all these generative models out in the wild, especially for text, then at some point it's plausible to assume that like a good chunk of the internet data will be LLM generated.
That's already the case. Right? Already the case.
There you go. Right?
And that's ruined because of it. But yes.
So you have that situation, and if we subscribe to this model collapse, I mean, there's other vectors that like to explore that why it's problematic, but purely like from an ML point of view, you could freak out about data quality in the future, because basically we would regress to this, model centipede that we saw in that little diagram, where it just becomes worse and worse. Now, it doesn't seem so dire, actually. What matters here is whether you replace data, and this is similar to what I showed you in the histo use case, or you augment it or accumulate it. So if you accumulate data, you actually can get improvements in the test cross entropy. So here, this is also for language modeling, where you don't deteriorate like in the replace setting. So this gets worse and worse and worse with each model fitting iteration. But if you do this accumulation, which means you have your real data, and the real data is not going away, like it's still on the internet, and we also can create new real data. The proportions might change, but it's not just going away. So if you supplement that accumulated, usually you don't deteriorate a lot. You might not always gain a lot as well, which we saw in the histo use case as well. But I think this model collapse thing is maybe not as clear cut as it was initially presented, where we have this clear trend of, okay, with each generation, it's becoming more and more useless. Maybe the worst case is closer to, we might not gain a lot, but in some cases we might actually. And I think that's the kind of the discussion around the data generation that I see currently taking place, where we have these kind of two sides of the coin. Does it actually make sense to synthesize? And if yes, how can we find the pocket in this heterogeneous kind of optimization landscape where it makes sense and do the things, and then also discard it and just go back to these 4 lines of Python script that I showed in the beginning? Because if it gets you close enough to what you want to do, then you don't need a diffusion model, and you maybe also don't need to go out into the wild and search for a lot of data. You can just do something very cheap, keep your costs low, and get a good bang for your buck. All right, maybe one little tangent here. So I think the challenge is you can do this performance-based evaluation, but if we build foundation models, we might not always be able to do this kind of task-based, multilateral kind of downstream analysis. And then the question is how we evaluate the stuff that the foundational generative model is doing. And I brought this figure by Ahmed, who was also co-author on this histo paper I just showed, and he has a really nice position piece on the evaluation of the faithfulness of synthetic data. And I think that captures quite well the tension that we have, right? So we somehow want to be in the support of the real distribution. So it should look like the things that we have in the data. But if we just have, if we just sample from the PR here, from this blue sphere, then we get stuff that, it's like memorization or a copy paste. So we want to kind of nudge it a bit out of this original distribution, but also not too far, because you can, the furthest you can go out of this real distribution is, or very far you can already go by just sampling noise. And this is probably also not what we always want. Not always, right? Sometimes we might, I showed with this dead leaves sampler. But if we have a foundation model and the goal is to have some images, the question is, how do we measure this? That is this actually good? Like a kind of shitty microscopy optimized thing that I showed? Is this actually good? What do we want from the foundation model to do? And if we don't have access to all the downstream task models, how can we measure it and how can we steer it? And Aji, also a colleague, I think some of you guys know well and work with, her group, they did this really nice piece on the Vendy score, where they built basically a kernel based diversity metric that allows you to assess for a data set how varied it is based on information theoretic quantities. It's also not, like rocket science or something, but what I like about it, it's very well formulated and clear. That's it. And we basically want to, if we want to optimize for diversity, we want to make sure that these differences are high between the data points. And we tried that in another with Gabriel. So this is the work that we present at NeurIPS this year on it's called generative fractional diffusion models, where we basically use some of these ideas that Aji developed for the notion of diversity to steer the data generating process directly and already during the training, so that we increase diversity. And how can you do this for a diffusion model? So if you look at this 1D, there is this stochastic path for the noise, and imagine you can control how much you wiggle that path. And what that means for pixel is like each wiggle is basically a range of values you explore in the in the pixel space, right? So the concept behind it is to say, okay, if we can control the range of values that we explore and modulate that a bit during training, can we get more diverse set of points out that still that still have the forcing function of the diffusion objective, which is high fidelity, but with a higher variance in representations. And let me see, like
that control is like at each time step of the diffusion process. So
yes,
you say at this time step, this is the range next,
exactly,
and depends. It's
Yes.
dependable on the previous range
Exactly.
that you found, and that's why you get those.
exactly. So the challenge here was also because usually you have not fractal Brownian motion, but Brownian motion. And the challenge here was when choosing that Hurst index, which is basically the control for how rough that path is to make sure that we can still plug that into kind of the overall diffusion framework and all the assumptions and the formal definitions hold. But that's exactly the case. So you can control it with the age, make it smoother, make it less smooth, and by that token, explore the range of values in the pixel space. And it's even qualitatively, I was surprised because it was very mathematical work. So a lot of the effort, especially by Gabriel, former student of mine, like went into coming up with a framework. But to me, at least, like even qualitatively, like you can quite clearly see the difference. So on the left, you have like a very smooth trajectory. And then on the right, you have this super diffusive regime with a high Hurst index. And you have a quite like visually a bit more like busy images. And this is just qualitative. We obviously used Aji's metric to measure that. And then this is not this one's the Venn table. So here for the number of processes, so the last column, you have the Venn score. Depending on the number of processes, we get a trade-off of fidelity. So fidelity, FID score, lower is better. And then for the Venn score, higher is better if we are targeting diversity. So it's also here, it's a bit of a trade-off between the two. So these two metrics don't perfectly correlate, which goes back to that graph that I showed you of Ahmed. And I think this is a good intermediate step. So now we have a metric, or let's say a measurement for diversity, but I think ideally we go a step further to define some proxy of task utility, and that's something I'm very interested in at the moment. Is can we estimate task utility regardless of some of these traditional? Because a lot of this still comes from the GAN days, where the goal, the goal of the class was to have some pretty images, which is, and for some use cases like in art, I think it's still very relevant. But for this kind of line of work that I showed earlier around the camera that we emulated, the real question, I think, at a large scale is how can we make sure that we basically spend the GPU hours such that we optimize for what the task model needs. And again, using this, the two extremes will be Python script that leaves versus a diffusion model. We make sure that we pick the right direction when we are at this crossroad. All right, maybe let's do a quick decompression. So there's like two more things I want to touch upon. Taking this like this work and moving it, like scaling it up basically, and what we need for it. And there is some infrastructure topics involved, and then the open discussion. But maybe just quick time check. Like, when did we start? Quarter past. So we have like 20 more minutes or something like this.
Yes, but we have to have a bit of discussion.
Yeah.
With the time up.
Yeah, for sure. Also, we don't need to do everything, and like we can like pick and choose a bit. So far so good. I mean, is there like, do you? My main question I think would be if you agree on this premise that we should push for more kind of task optimized data and ways to achieve that along this life cycle. So this includes some like bits and pieces, but also kind of indexing and data infrastructure around it. Or do you say, okay, Luis, this was all nice and fun, but I think it's bullshit.
Is all like focused about image? Do you have anything about text?
No, all the work we did, we have one evaluation, like this benchmark, also with ML comments, but it's more focused on the downstream metric for LLM model evaluation. But most of the stuff we did over the last 2 years is only images.
Yeah, if we summarize, like, it's a few take-home messages, and I'm sure people will also ask questions.
They also, online.
You make a few summary.
Yeah.
Comments and questions.
I think we will do like a comment and question discussion, or do you want to wrap up and then?
Yeah, probably next year. And
All right, then let me just take a sip of water. I wrap up. Also want some? All right, so then let's have a quick look at the last two pieces, right? So out for a moment, regroup a bit. Okay. So we talked about this measurement view. We now spent a lot of time on this, the data generation process. I think so let's maybe bracket out this a bit and like finish with a little like, core values on this part. So if we agree on the premise that we want to push for data generating processes that we can control and measure so that we reduce the transaction costs, one big piece that we haven't talked about is the infrastructure that allows us to do that. And that, I think, has it's its own can of worms, but it's also, you can do, like we did some, I think, cool stuff, and not just us, like many people, especially from the database community. There's a lot of very interesting startups, like Lance, for example, by Chang Shea and colleagues. He's a former NumPy maintainer. That they build a really nice query interface and loading interface for L datasets so that can do this indexing environment. But let's not get rare. My point is just that there's a lot of good work happening in this space, and I think this is also an opportunity for different stakeholders like Microsoft, like ITU, conferences in particular, to connect. And I just want to maybe then briefly teaser this. So this is the Croissant project that we have been working on to power some of this infrastructure behind what I mentioned. So Croissant is we started as a funny group of people from different organizations. with like this similar kind of ambition to make sure that we have a simple interface to index and use the data assets that we have in machine learning in an easy way. And this is, I think, a perfect visual abstract. So what you can do with Croissant is you package your data sets, also text for if you want, in a Croissant file. But also most of the large repositories already do that now. So if you go to Hugging Face, for example, and you click on any given data set, you can already download the Croissant metadata here. So if you create a data set on Hugging Face, it will pre-generate that Croissant for you. So you can publish it also on your own website. You don't have to go through Hugging Face, but since many people do that, that's an easy kind of way to interact with the format. And then you can pull it. I won't go through the full demo so that we can dive into questions. But the way you interact with this Croissant is like, yeah, it's just like a URL. This links to the data set, and then you can already start working with it, training a model in different frameworks. And going through the TFDS route, we can then export easily to PyTorch, JAX, and Keras. So you're good to go. And you have one shared interface and across different platforms. So it doesn't matter whether the data lives on Kaggle, Hugging Face, OpenML, now also Dataverse onboarded it. And it's hopefully growing. Allows you to have this kind of shared representation, and also allows you to do these type of large-scale measurements and compositions of different components in the life cycle a bit less painful. And I think I will leave it at that for now. So to go into the discussion, I think that would be very immediate topic of interest on the infrastructure side, next to this data utility and synthetic data. So if you think like, oh yeah, this is something we've already solved, then it would be really cool to know how you solved it. And if you think, I think this needs to be solved, then there's a big group of people who are looking for contributions. It's all open source and has some good momentum. But yeah, I think if we want to make this index, and especially this kind of task problem catalog of the ML universe, then we need something like this as a backbone. Otherwise, yeah, it will be hard to kind of tie this substrate together. Yeah, I think, let's leave it at that. And I will, so let's have some discussion. And in the background, I will start a little, this is like bleeding edge, basically. It's a demo for kind of what could be one step, kind of going beyond just a format for data sets, but like a task abstraction in the similar vein. But I will start this up and see if we get to it. And in the meantime, we can already start discussion. All right. Thank you guys for powering through 1 hour of, it ended up being a monologue. I tried so hard not to make it one, but once you get going, and then it's just like a train. Yeah, feel free to ask also online, or if you have orthogonal topics or want to pitch your own stuff. This is a fair game.
Yes, thanks, Luis. Great presentation. I will give priority for folks online. Any questions about what Luis presented? Given data infrastructure are key components in ML pipeline. Of course, when you bring it into local context, it may have different forms, and I'm sure you may have a few other questions. I see Gilles, Millicent already online. Any questions from you first before I give chances to those in the room?
Yeah, thank you very much, Luis, for this very nice presentation. Actually, I feel like there's a massive amount of things that I definitely need to dive more into. But one of my takeaways is that the goal is to build an infrastructure that minimize the cost of entry when it comes to running any ML task, right? So how do you see this applied in the context of geospatial machine learning, for instance, where sometimes we have, especially when we train models to run globally, I mean, most of the time, the data has so much diversity that the model doesn't generalize well. How do you see the application of this, especially when it comes to sampling for training?
So my fever dream for this is that we have basically another layer of models. Like I think the closest approximation I have is like in quantitative trading, where people try to estimate market prices a few kind of into the future, and I think it would be something close to that, where we take, for example, you have a list or pool of possible data sets, you have a pool of possible augmentations, you have a pool of possible like generative models that you could either sample from or first have to train and then sample. And then this estimator gives you a ranking of all of these different pipelines, so that you end up doing like a bit of a kind of triage on how you approach the problem. And there is like a lot of work on this in like AutoML, for example, or in active learning. So these are not all new concepts, but I think we haven't really applied them at this, let's say, Croissant scale, where you can basically run it across all the major platforms and then kind of avoid those high transaction costs regimes where you do like what I showed with the histodata stuff, right? Where you do all these cycles and then halfway throughout the process, I'm thinking like, okay, why actually are we doing this? Like synthetic data for this use case, it doesn't even like make a lot of sense. So this would be my kind of aspirational answer to your question.
Yeah,
but I don't know what.
Thanks a lot. Actually, I mean, even in the context of geospatial ML, and when we are trying to run like models globally, actually we have access to, I mean, petabytes of data we could pull out from. So I mean, even if we don't get to the augmentation step, we already have a huge challenge in selecting even the data from, itself. Like we cannot train on everything, right? But we also want to generalize on everything. So I was wondering, like you mentioned the Venn score, and so I think Aji presented this work last year. So is there any like have you guys deployed this and is it like usable? Like if I have a bunch of satellite imagery, can I just run a script and be like, okay, this is the set of areas I can just select from, and I don't need to go beyond that to generalize?
So I mean, for the purposes of our analysis with this fractional stuff, it was point on, because our kind of motivation when we started was to approximate diversity. So for that, I think it's great, and there's probably other use cases, but I think I know the stuff that you are working on, or at least the problem. I think when Gilmar once told me about it, that is also evaluating, right? In satellite imagery, you have this huge issue that you basically have almost infinite data, and you need to make sure you need to pick basically what frames you want to see, and discard maybe also some that are not useful. So you are somewhat in the opposite side of the kind of scarce data setting, but it's still a problem of identifying what's useful in there. And I just pulled up here Rushi's profile because her group has been doing some really cool stuff at the intersection of data evaluation and data markets. I will try to find the paper I have in mind. So one of her PhD students, this I think it's maybe I think he also presented as a spotlight at NeurIPS last year. So what they do, for example, which it's okay, short answer. So they try to estimate before you train, you basically have some data and then they have a method, a model that something what I just said for the stock market that estimates before you train, estimates your training outcome if you would train on that data set. And I think that's the line of like work I would look into for. Sorry, I think this didn't come through. Jill, was it Jill?
No,
Yeah,
nothing.
Okay, sorry, it was just somebody in the background. Yeah, so I think that's the line of work maybe beyond the Venn score that is the actual holy grail, right? Because the Venn score, I think, is not trying to estimate data utility, it's trying to estimate diversity. And where this is the goal, I think it's a wonderful metric. But there's other, I think that what you are mentioning goes maybe a step beyond. So in the best case, diversity maybe correlates with that data utility, but I don't know if it always needs to be the case that if you have more diverse data, you will get better task performance. There's probably some also non-degenerate examples where this is not the case. So yeah. Anyway, also all those links, I will do a dump and then send it around. So then.
Yeah, thanks a lot. And something I think I also need to maybe dive more into is I've always assumed that like diversity, more diversity would like literally lead to increased generalization, but maybe not actually. So that's something would be cool to dive into. Thanks a lot.
Yeah, thanks so much for the question.
Yeah.
All right, anyone else? Don't be shy. If you have some crazy ideas, this is the place to share
In the
them.
room or online still? Let's do online.
Yeah. Then we can start here actually. Start. You have any questions?
I don't know. I guess I don't really buy the data scarcity reason of why synthetic data is important. I agree. So many people are actually having the problem of too much data, not necessarily not enough. I think our models grew much faster than training data did. And so there was this inflated fake demand for real data, just because now we've got hundreds of billions, possibly trillion parameter models. So yeah, I'm not that concerned about the model collapse type questions and that we're hitting this scaling issue because of lack of real world data. And in fact, I wonder if we should work on a paper that looks at, because all of that model collapse paper was assuming that model was being used for the generated data was being used at pre-training. And now, within the last 6 months, the world is going into some pre-training, but now inference compute. The inference compute is essentially synthetic data generated on the spot to help at inference time, to help this algorithm figure out its thought processes. So synthetic data is coming in to our models, but not at pre-compute, pre-training time. It's coming now at inference time. So I wonder how much of that model, how much of this kind of model collapse prediction still happened if you take away synthetic data from the pre-training part and actually say, let inference time compute go crazy on synthetic data, but keep your pre-training as close to real, 01 or version 1.
Yeah. It's a really good point. Yeah. Like there's this Shankar, she just released this, I think it's doc-ETL. That's where the other database people there. They have so many hidden nuggets of cool stuff. And I think I mean, it looks at it. I'm lost. No, here, Docker. It looks at it from a bit different angle, but the idea basically is very much what you are saying is to use the synthetic data during inference.
Yes.
I mean, you get like crazy improvements also for the performance outcome, because you can iterate over what the model has been doing, and then get a lot further just when you do a few of iterations, refining how you instruct, plus match it with the kind of structured output schema. So if you know this thing is supposed to create, like communicate with some API or fill in some JSON, providing that context is also like a crazy forcing function to improve the performance of this output. So if you pair it, I agree a lot with that.
You have RAG data, some context, and then just prompt engineering.
You have the context, but also you have so basically you already at the output tell the model what it should fill and use that information during the prompting, so that you can steer it towards that schema that you need, right? And for many kind of larger machine learning systems, this is like the main communication is they're going to have is with some API that then does something else with it, right? And that's a good point. Sure.
And, I think this is what they used to do, synthetic data in text. So what we do, like normally, like you have any model that LLM for Arabic or English, any language, and then you just have some context and prompt engineering how you want your outputs without caring about what the model has been trained on. That context just give you like good quality data. And then maybe after that, the challenge is how you can measure it.
Yeah, I think there the question is really the secret sauce is in how you proxy the utility, and so either you find some like good general purpose metric that correlates well with a lot of downstream stuff, and I think like if you look at LLM evaluation, this I think has worked quite well, but also we're at a point now where most of these benchmarks saturate, and so it's an active problem actually there also to just figure out, okay, what's the next utility signal beyond the existing benchmark, because we cannot go beyond 100. And there, from practice, we still know there is gaps in what, like in the behavior of the model to what we wanted to do.
Yeah.
So I think it comes down often there to that question, how well you can characterize that downstream utility and don't get lost somewhere along the way, assuming, okay, it should be only that or this, or it should be FID, and then you end up with a model that doesn't really do your segmentation downstream, like fine-tune segmentation model.
Yeah, I think this is why they got the idea of red teaming. Make sure that the model will be.
Yeah, exactly. I mean, they're right, trying to do that, develop harnesses for the model to do that type of evaluation.
Any other questions?
Another comment, but it's less technical. So.
No, actually, before that, I just follow what Jules mentioned in a bit Sky. This task-specific data generation assumes you own the generation process a bit, because sometimes in geospatial remote sensing stuff, you just don't have much experimentation on the data generation process. So how does it work in that way? So two, like resource-wise, usually we have the perception that there is a lot of silos data around, and we try to use them in effective manner so that one data could be used for different tasks, actually. Even if they have low quality, still you try to make something out of them. And how that just generate the task-specific data assumption work in real case, if you try to work even some local problems in agriculture and all that. So these are sort of my questions. Third, since I get the chance, You have been working with ITU in regulation and all that stuff. How does this approach bring another layer of complexity to regulate audit machine learning pipelines, especially in healthcare?
Is that the work of ETU or
ITU.
ITU?
Yes. ITU.
Someone from
AI
ITU
for Health focus group. Yeah.
coming to Nairobi in January. Talk about that in a second. Okay.
Yeah. Yeah, I think so. Going backwards, so I don't know. I mean, there's this meme, right, with the standard stuff. Like this, you have some people saying, "Okay, we need a new standard for this," like some Croissant, for example.
Yeah.
And then you work on it, and you get some momentum, and then 2 years later, it's just another of 16 existing standards already. So I think, I don't know, like there is obviously some complexity and overhead and bureaucracy involved. There are success stories. So I mean, UN organizations in general, but also ITU, I think they're sometimes look down a bit upon, like, okay, they're just sitting there, pencil pushers or whatever. I don't think that's the case. There's especially in technical standardization, whether you look at compression or things like this, they had huge success stories. I'm not so sure sometimes, at least at the moment in machine learning, how much value it brings, because I feel like we are one of the communities where we are quite good at doing open source. Like we kind of develop our own standards. Like it doesn't seem so to me that we need a outside forcing function so much to help us play well together. But I might be mistaken. Like maybe there's parts I'm missing. I'm also so Simao from also the previous focus group. Like we have been talking also with Thomas whether we should have like a parallel activity inside of ITU to build this index, because they have every year they have this for good summit, right? And it's a good opportunity. So now, for example, in Europe, they use Croissant. So the hope there would be that 5 years down the line, every DB track submission that has a data set, they will all index to Croissant, so that you can retrospectively then also query and compose with that format. But you always have this kind of build-up phase where, like I was mentioning, this driving car, right? Like the vision is maybe clear, but the materialization not so much. And so I don't know. I'm a bit uncertain with this what the standardization could add, but maybe also we need to ask ITU. Like maybe they have some really cool suggestion. Yeah. And for your first part about the task and the control, yes, it's I think you can only go as far as you can, right? So if like we work also a lot with like satellite manufacturers that do the acquisitions. So for example, Planet, right? They are a big satellite manufacturer, and then they also do the like downstream application in terms of like image preprocessing and stuff. And like these kind of actors, I think are interesting partners to look at for having some more control. But at the end of the day, to me, it's more about making sure you push this modeling paradigm as far as you can. I mean, there's always going to be a limit, but if you are able to at least capture the data value after the process stage and estimate it correctly, then you're already, I think, better off than training 2-3 different generative models and burning through GPUs and then maybe having the similar performance, right? So the utility part is just a guiding function, I think, to make sure to estimate that early on process.
Cool. I know time is up, but if there is any last question from anyone?
I'm just going to leave this paper up because I think we don't have time to go into it, but it touches especially on what you were saying, like for the representations. Maybe we can discuss later on another time.
Yeah. We organize this seminar like Microsoft AI for Good and Microsoft Research Africa together. I know Millicent is online. Millicent, you wanna make a comment or two before we
Not really. But, yeah, thank you very much for such a wonderful presentation. Yeah, it was quite informative. We truly appreciate you coming in person there.
Yeah, thanks for having me. I mean, it's nice to see all the folks.
Yeah.
There is one point I forgot actually. Aisha is also here along with Luis. She's really very active in organizing communities in Africa, focusing on AI, machine learning. That includes deep learning in Java and Geo AI community. Given you are here and this is like-minded folks, do you have one or two sentences to make about those efforts?
Yeah, thank you so much, and nice to meet everyone. So yeah, I don't think we have enough time for presentation, but I wanted just to say some words about the community that we're establishing here in Africa about geospatial AI. So I think we are coming from Masakani, so the same goal, like we want to build some local community, but collaborate also
around geospatial particular.
Yeah, exactly. And then the idea is create this open space. It's going to be like inviting collaborators, students, getting some resource if you want to learn about geospatial. And also the idea is having some proposal for idea related to geospatial. So from all the continent, and then we'll collaborate together. So we have just started last year creating this community. So our group from Microsoft, Girma, Jules, Akram, Julian, and myself, Sabrina, different research from different companies or university. And then the goal is having mentorship program for students or people who are getting into geospatial. And then also organizing some events in the continent and outside. We started I think organizing now 5 workshop and in summer schools, including in Daba, computer vision summer school here in Kenya. The last one was a workshop in Senegal. So the idea is now we have the core team and we are overall if you want to join the core team member, or if that means task would be 1 hour at least to be committed to the community for 1 hour per week, or maybe advisor, affiliated member, or also just join the community and be there. We have already started by having hackathon in Daba, and it's going on now. I don't know if I should just
Go for it.
Yeah.
Did you? I stopped sharing. Or do you?
Yeah, it's fine. I already have slides.
Are you in Teams, Aisha? Or
Are you already joined?
No, I didn't.
you can send it to me. I can also share it.
All right.
While I do that, I will ask 2 questions already.
Okay.
So are you guys indexing data as well? Can you? But you have to send me the slides.
Okay. I just sent it already.
I know Jules is also online,
Yeah.
and you can address some questions, Jules, about the community.
Yes, of course. The only question I heard is, are we indexing data? Is that?
Yeah.
Yes.
Yeah. Okay, I think we haven't started that, but that's actually a good direction we could take. Right now, we really started with building some learning resources, trying to find good problems where we can start with. But I think, yeah, the data indexing part, especially in the context of Africa, is something important. So I think we should keep this as a good point, something we should work on. Yeah, maybe Julian, if you want to add something on that. I know we currently very working on consolidating the team, but I think these are points we want to also touch on. Yeah.
Actually, I think you have to join. My hotspot died with super timing, so I don't have internet actually. I'm not even in the meeting anymore. Are you as well? Okay, that's why my internet, my phone is off. All right, so we figured out.
Give me your own, right?
But I can turn it back on.
Cancel it?
I think maybe you just could share it around.
Oh, you're okay. Can you share?
Or this way.
Better if I share it directly?
Yeah.
Yeah?
Sure. Thank you.
Okay. Give me 1 second. I just need to.
Perfect timing. Yes, another question. So the indexing, and you do the summer schools, right? You said?
Yeah, we did like some shared learning, some practical in some school.
Because Thomas and another colleague from DMLR, Manil, he does all the AI stuff at NASA. They are, I think, planning for a summer school in Geneva. I don't know if it's early next year, but it has basically the whole mandate, I think, that you envision is to bring in students. They have some resources. Yeah, maybe you guys could have a chat. I can send an email with you and Jill.
Okay.
And because I think they have all the resources in place, but they're still early enough to receive some like curation and direction with your experience.
Okay, good.
There you go.
Yeah, this was the last
Yeah.
event.
So Aisha, where should I go? Just lead me.
Yeah. So just trying to enable
Yeah.
the
So-
back end and then background. Who can join? Yeah. So the community is open. The community is open for everyone, like undergrad, master, PhD, and just deliver academic junior and everyone who interested in geospatial. Next.
Yeah.
So we're growing. I think like we started last year. I think was November, right? Then now we have opened this like Google form to join us. We have 9 response from all the content, and most of them from Kenya. Why the reason? Because we started here in the summer school, so we got like new students interested in geospatial. Yes. Yeah, I'd say like we started by having some tutorial introduction to geospatial, and then some geospatial technical machine learning. Also, we had some, I think, crop, like I think Akram was doing some tutorial about. Can you remind me? Just the crop was in Africa, right?
Yes,
Yeah.
yes. So actually, first, we started with those introductory notebooks for people learning geospatial ML, but we also have what we call the participatory land mapping tutorial. Actually, it's a full it's a notebook giving a full pipeline of what it looks like to use satellite imagery and so on. And so from satellite imagery to segmentation type problems. So this is particularly focused on land mapping. Yes, I think Akram is not around. Otherwise, he was the one leading this endeavor. Yes, the hackathon Aisha was talking about that we run at the Indaba. So it was mainly leveraging satellite imagery. Let's say leveraging LLMs to label satellite imagery, because we know that we have an abundance of satellite imagery, but most of the time the problem, especially in Africa, is that we don't have labels. And one of the reasons why global models don't work so well in Africa is because of that data scarcity problem. So the hackathon is mainly to address that problem. Yeah, Aisha, I can pass.
Yeah.
I can get the floor back to you. Yeah.
Yeah, I think also getting back to this question, I think we are also interested in having like some data sets local in Africa, like especially for different like downstream tasks, and maybe like I don't know, we'll use some of your knowledge about that center.
And what is the name of this? Is it the Lacuna Fund?
Mhm.
They are doing aggregation, but only for healthcare data or also for?
Have agriculture piece as well.
Yeah.
Okay. because that could, I mean, this would be anyway a good, I think, group to talk to.
Yeah.
Also for for these data standards.
Yeah.
If they're interested to index.
Yeah, so the idea is like also looking if we can gather all the data in one place. I know like Girma mentioned we have like a lot of data in Africa, and how to get access to it, how to get well organized, and maybe some features. So if we can also like have something like that in the content, that's one of our goal like for the future.
But what is this? So this is from African, that is by satellites owned by African countries? What does it mean?
No.
Most of the time it's publicly available from the ESA, European Space Agency.
Okay.
And some partners like Planet.
But it's maybe curated already for specific use cases.
For specific use case, I mean, there are so many players in town working on, for example, agriculture. Everyone has their own grant data, but they are in silos. Some of them good quality, but always the effort is like, how could you combine them for effective use? So
because there is this, I mean, there's lacuna, right? And then there's I think so. I
know we are running out of time. People are online. Let's wrap up and we can continue the discussion offline.
Okay, yeah. So what you get from the community, as I mentioned in the beginning, we have like for undergrad or like early students, like some learning opportunities. You can get like some reading groups or maybe get into projects. And then here we are taking some challenge in the content, and then we started calling for proposal like from all the contents. If you have an idea that you want to share for the community, then we'll start working together. And also have a space to Slack and Twitter for sharing some professional and other opportunities to students. And we're open for partnership, also collaborations from university, like academics or industry. So feel free to get that's if you're interested.
Perfect.
Yeah, I think that's good. As I mentioned, we have different roles. Like you can be benefit in the community if you want. It's just going to be 1 hour per month. With the mentee, will be marked choose one to one mentee. Next, that's one. And the overall now we have a core team already, but we are trying to get more people into the core team. So you'll be convinced for 1 hour per week and advisor 1 hour per month. Can be active member in the community or can be affiliated member. So we're just starting and looking forward to us.
Has building a natural language interface to these geospatial models come up before? Allow someone to sit down, ask a natural language question of satellite images. They can describe maybe a part of the continent, maybe a guess at a season, maybe, within a time range. Has that
No,
come up?
I tried this with this like general LLM doesn't work, but I haven't seen specific. Yeah.
There are some efforts already trying to link these two, but of course, geospatial ML is very different in many aspects. But there are a couple of efforts like Queryable Earth where we try to just prompt and try to get some geospatial insights. But one aspect is like how to label. Of course, you have a lot of data, and as Jules mentioned, usually you don't have label, but how to label automatically at scale quickly is one effort that have been. But I think there's a growing interest in that.
Yes.
Let's continue this offline. There are a few people, Millicent, Dion, Toby. Thanks for joining. Importantly, Luis, Karibu, Kenya, and thanks for great presentation. Aisha, welcome back again. We appreciate the efforts. Thank you very much.
Asanteni sana, Gima. Thank you very much for moderating and welcome all. It's so sad I'm not in the office, but I'm excited to see everybody.
Thanks, everyone.
Yes, thanks everyone, and bye-bye.
Let's meet in Benin.
Yeah.